Hello, everybody. So we are starting our last unit before semester one ends, and it's a short one, just like conic sections was short. And we're going to start off with expanding binomials using something called Pascal's triangle. So here's Pascal's triangle, and it's a work of art. And if you like numbers, you're going to love this. But even if you don't like numbers, I can convince you to appreciate this at some level. There's lots of cool patterns here. Notice it goes, the natural numbers are right here, 1, 2, 3, 4, 5, 6, 7, 8, etc. But the, there's also this hockey stick pattern where if you take 1 plus 2, you get 3. 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 plus 4 is 10. And they call that the hockey stick pattern because it kind of shapes like a hockey stick. But no matter where you start, it'll still work out. 1 plus 4 plus 5 plus 20 is 35. And 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 28. And there's lots more. One more just to just indulge me really quick. Actually, two more. This is called the flower pattern, where if you take the numbers 4 times 5 times 10, you get, let's see here, 4 times 15 times 10 is 600. And then if you take 5 times 6 times 20, you also get 600. So this is called the flower pattern. And if you kind of pick up and move to a different flower, you'll have the same situation. 15 times 56 times 7, whatever that equals, is the same as 6 times 28 times 35. And there's probably a dozen more. But the one that we're interested in is that the two numbers above a certain number, if you add them, you get that lower number. 3 plus 3 is 6. And that pattern helps us generate the whole thing. 1 plus 4 is 5. 6 plus 15 is 21. And on you go. So what are we going to do with this thing? We're going to expand binomials. Here's a binomial, x plus 1. X plus 1 is a binomial. If you raise it to the 0 power, it equals 1, because anything to the 0 power equals 1. If you raise it to the first power, it equals x plus 1. If you raise it to the second power, this is algebra 1 now, x plus 1 times x plus 1 would give you this, x squared plus 2x plus 1. If you raise it to the third power, so x plus 1 times x plus 1 times x plus 1, you would get this. Now, do you see a connection between expanding the binomials and the Pascal triangle? Hopefully you can see it's about those coefficients. The coefficients here are 1, 3, 3, 1, which is exactly this row. The coefficients here are 1, 2, 1, which is this row. The coefficients here are 1, 1, which is this row, etc. So that's the connection, but it's a little bit more involved than just the coefficients. In fact, the coefficients might be a little bit misleading. The reason why it's 1, 3, 3, 1 is because this term is 1x. But if this were 2x, it would be 1 times 2, 3 times 2, and etc. So let's see how we use this. So when we expand any binomial, a plus b to the nth power, we can use Pascal's triangle. We identify the a and the b terms. The a term is going to start off with the nth power. And then as you move along, term by term by term, it's going to go down 1 degree per term. And then the b value is going to start with b to the 0, and then that power is going to go up term by term by term. That's kind of confusing, so it's easiest to look at an example. So here's an example. We're going to expand 3x plus 7 to the third power using this triangle. A equals 3x and b equals 7. So the first question is, what row do I use in Pascal's triangle? Well, remember, if you were to actually expand this out longhand, like do 3x plus 7 times 3x plus 7 times 3x plus 7, you would have 4 terms. You would have an x to the third term, an x to the second term, an x to the first term, and then a constant. That's 4 terms. And if you look at your rows, there's only one row that has 4 terms, and it's this one. So I'm using this row for Pascal's triangle. And I call these are called Pascal numbers, all these numbers in here. So how do I use this? Well, the garbage that I put up on the last slide here. The A term begins with the nth power. The B term begins with the 0 power. And that A term increases, I'm sorry, it decreases in size. And the B term increases in size. So keep that in mind when we go over this. So here, look at all these terms. I got 1, 2, 3, 4 terms. Terms are separated by plus signs. And in each term, I have a 3x and a 7, right? 3x and a 7, 3x and a 7, 3x and a 7. That's the A and the B. But the A term started off with 3x to the third, and then it became 3x to the second, and then it became 3x to the first, and then it's 3x to the 0. The B term does just the opposite. It starts off with b to the 0, so 7 to the 0, and then it grows 7 to the first, and then 7 to the second, and 7 to the third. The Pascal triangle comes into play here. These numbers are being multiplied by each term. So 1 times that first term, and then 3 times the second term, and then 3 again times the third term, and then 1 times the fourth term. So if you can successfully get here to this level, then you should be good. But history tells me that that's not always the case, because sometimes we're a little bit fuzzy on our math skills. Remember, the only thing you're adding 4 things, but you're not going to have any like terms. You're not going to have any like terms, guys. So if you're combining terms, something went wrong. You're really just multiplying. But there's another operation, exponents. Exponents come before multiplying. So you need to evaluate each term on its own. Figure out what that term is, then figure out what that term is, and then this term, and then finally the last term. And if you can follow the operations, then you're great. Well, let's see here. I can't do 1 times 3 just yet because 3 is in the parentheses, and that's being raised to the third power. So I got to do 3x to the third power, which is 27x cubed. And 7 to the 0 is just 1. And 27 times 1, well, that's just 27x to the third. That's my first term. My second term, I can't do 9 because I can't multiply before exponents. So I got to do 3x to the second power first, which becomes 9x squared. 7 to the first is just 7. And now it's all multiplication, guys. There are no more exponents to be had. I mean, there's an exponent here, but that's on the x. So it's just 3 times 9 times 7, which, go to my calculator, it's 189 times x to the second. That's the second term, plus the third term. So 9x to the first. Here I am. Oh, no. This should be 3, my friend. Oh, no, that's not my bad. I should have trusted myself. Let's go back to the top. 3, the Pascal number, 3x to the first, and then 7 to the second. So 3x to the first is just 3x. So I can do 3 times 3x, which is 9x. And 7 squared is 49. And now I can multiply these two. 9 times 49 is 441. And then x. For some reason, students have a tendency to add these two things right here, and they end up getting like 15 terms as your final answer. So this assignment will either be just an absolute breeze, walk in the park for you, or it will correct your bad habits with order of operations. So it's good in either case. Finally, Pascal number is 1. And then 3x, remember 3x started with the third, now it's to the 0, so that just becomes 1. And then times 7 to the third, which is 343. So here's my final answer. Now I need you guys to pause the video and evaluate this. Pause the video and work this out. I sure hope you did pause it. You should have gotten that as your final answer. Next example. Find the first 3 terms of this expanded out. Now this is being raised to the 6th power. Okay, so which row do I use for my 6th power? It is this one. A little shortcut is the second number tells you your exponent. So I'm raising it to the 6th, so that's this row. And I got 1, 2, 3, 4, 5, 6, 7 terms. Luckily, they're only asking for the first three, so don't do more than what's being asked. A is 5x, B is negative 9y. So my Pascal numbers, 1, 6, 15. 1, here's 6, there's 15. And then for each term, there are only 3 terms because I only going to find the first 3. I've got an A and a B, A and a B, A and a B. The A starts off the biggest, A to the 6th, because it's being raised to the 6th, and then B to the 0. And then the A goes down, the B goes up. So A to the 5th, B to the 1st, A to the 4th, B to the 2nd. And also, if you're really a keen observer, you'll notice that these two exponents, 4 and 2, 5 and 1, 6 and 0, they'll always add up to this exponent right here. That was also true in the last two examples. And that's true for all of these. Now, can you evaluate correctly? Well, negative 9y to the 0 is just 1. So 5x to the 6th. X to the 6th, everyone gets that. But not everyone gets this. The 5 is also being raised to the 6th. That's why it's in the parentheses. And then over here, you forget about if 30 entered your mind, you got to control yourself. This is not 30 at all. This is 5 to the 5th times 6. So you got to do exponents first. 5 to the 5th is 3,125. And then now you can multiply by 6, giving you this monster, 180, 100. Oh, actually, even before that, negative 9 to the 1st, you're multiplying these three numbers. 6 times 3125 times negative 9 gives you a negative number. And then the third term, the 5x to the 4th becomes this. The negative 9, while you're squaring a negative, that's always a positive. So it's positive 81y squared. You multiply these out, and you get this. This is definitely one of those topics that looks easy when it's demonstrated, but when you try to do it, you don't know why you're not getting the right answer. So you really have to please do the homework. All right, now you guys try. Pause the video. Notice this is 2x minus 5y to the 5th. So be careful. Pause the video and work this out. Well, I certainly hoped you paused it. And since it's to the 5th power, you are using this row right here. And you only have to find the first 3 terms. So I believe this is the correct answer. Last example. Find the 3rd and the 6th terms of the expansion of this. Ugh. So this is raised to the 5th power. So we're using that. And if I want to find the 3rd and the 6th, then this must be the 3rd, right? 1, 2, 3, 4, 5, and then this is the 6th term. So I'm only using these 2 Pascal numbers. Starting with the 3rd term. Well, I know it's going to be 10, but times what? You always multiply A and B. So it's going to be an A and a B. But the question is, what power? Well, remember, A starts off with the biggest. So this right here will be A to the 5th. This is A to the 4th. And this would be A to the 3rd. And then B always starts off with 0, and then it increases. So B to the 0, B to the 1st, B to the 2nd. Be careful. And then you can also do that little trick. The 2 exponents, 3 and 2, add up to 5. They always. So once you knew that this was 3, this would have to be 2. And then order of operations, again, this time's exponential fun. A power to a power, you multiply. So you're not going to do 10 to the 3rd. 10 is not inside the parentheses. But you are going to do x to the 3rd, which is x to the 9th. And y squared to the 3rd, which is y to the 6th. You are going to do 2 to the 2nd because 2 is inside. So 2 to the 2nd is 4. X squared is x squared. And y to the 4th squared is y to the 8th. Now you can multiply. Everything is just being multiplied. So you can rearrange this however you want. The 10 and the 4 would become 40. Again, for some reason, students want to add here. I'm not sure why. But then x to the 9th times x to the 2nd is really x to the 11th. And y to the 6th times y to the 8th is y to the 14th. The 6th term, the Pascal number is 1. The a value will be all the way down to 0, a to the 0. Since it's the last term, the b value is going to be all the way up to the 5th power. So b to the 5th. Now this raised to the 0 is just 1, which is great news. But this to the 5th, 2 to the 5th is 32. X to the 5th is x to the 5th. And y to the 4th to the 5th is y to the 20th. And there you have it.